15 says, choose the compound below that should have the highest melting point according to the ionic bonding model. So there's a couple things we need to know. First of all, melting point and boiling point are directly proportional to the lattice energy. So the thing with the highest melting point also has the highest lattice energy. And there are two factors that influence the lattice energy. The first and most important factor that influences the lattice energy is the charge difference. I don't want to put that as a plus. So the charge difference. Specifically, greater charge difference greater lattice energy. Okay, so the greater the charge difference, the greater the lattice energy. If the charge differences are the same, then it's the ion size. But we only consider this if the charge differences are the same. Here, smaller ions, greater lattice energy. They're closer together, so it takes more energy to melt or boil them. Remember that the lattice energy is directly proportional with melting and boiling point. So the first thing we need to do is find the charges on these things. So if we look, okay, magnesium and oxygen, we have +2, 2A metal, -2, 6A nonmetal. So the charge difference here is 4. +2 minus -2 is 4. Rubidium iodide, +1, -1. The charge difference here is 2. So this has a greater charge difference, 4, than this, which has 2. So this is definitely going to have a higher melting and boiling point than this one. CAS, +2, -2. Okay. NAF, +1, -1. All right. ALN. ALN is a 3A metal, +3, and is a 5A nonmetal, -3. Here the charge difference is +3 minus -3, or 6. So this has the greatest charge difference and therefore the highest melting point. Now notice if you wanted to compare MgO and CaS, these are both having a charge difference of 4. So now we need to look at the ion size. And to do that we need a periodic table. Mg is here and O is here. And we're comparing it to CaS. Ca is here and S is here. In both cases, Mg and O are higher on the periodic table, and therefore they're smaller ions. They're closer to the top, and they're going to be smaller ions. So MgO will have a slightly greater lattice energy and a slightly higher melting point compared to CaS. So the charge difference is a greater factor. The difference between MgO and RBI in terms of lattice energy is going to be very high because the charge difference is very different. Between MgO and CaS, it'll be substantial, but not as high because here it's only the ion size that is the difference. So I hope that clears things up.